This is my video on the Huntington's disease mini lab, and it will provide you with some tips and tricks as you work through this lab. First of all, you'll want to start by reading the introduction and the information about building Nathaniel's family tree. The introduction tells you a lot about Huntington's, the man who first described this disease. And it also down here tells you a little bit about Nathaniel's family and the fact that Huntington's disease runs in his family. So the goal of this lab is to figure out whether or not Nathaniel and Jean's twins have Huntington's and to look at how it's passed down through the family. So once you read this information, you should have answered many of these questions in advance, but you'll answer a couple of these questions using the information on the previous pages, and then the other questions you'll answer as you complete the pedigree. Once you've answered as many questions as you can, you should grab this sheet of paper. This sheet of paper has pedigree data information from 4 different sources. So it says pedigree dataset 1, dataset 2, dataset 3, and dataset 4. These pieces of information are gathered from basically 4 members of the family. And this is how a genetic counselor might create a family tree, a pedigree to look at the inheritance of a genetic disorder. Not one person has all the information. So you're going to have to use all of this information to create your pedigree. So for instance, it says Horace has only one child, a son named Alan, who was born in 1916. So you have to find a location on this pedigree where you see a man that only has one son, okay, and only has one child, and that's actually right here. So we know that this is Horace. We're going to have to write a lot of information in these squares and circles, so make sure you give yourself space. Then it says, Martha married Horace in 1910 when she was 24 years old. Horace was 29 at the time. Their ages are inconsequential, but then you know, okay, Martha married Horace. As you read, it gives you more information. Martha's granddaughter, blah, blah. You'll use that information later, right? But then you can look through the rest of the data set. Martha died in 1951 at the age of 65 of what might have been Huntington's disease. She died before her youngest grandchild, Debbie, was born. So you'll use that information to fill in the rest. So, okay, you need to tell me when Martha died. So she was born in... Well, it says she married Horace in 1910 when she was 24 years old. So 1910 minus 24, 1880, 1876. Am I doing that right? Nope, 1886. That's why you shouldn't do it just off the top of your head. Okay, so 1886, that's when she was born, and she died in 1951. So she died at how many years old? So you have to figure out how old she is here, okay? And then you keep reading, okay. When Christina was born, anything about Martha? No, other information. So basically, you're going to fill in as much information as you can, how long they were alive how old they were when they died, right? Was she 51? Was she 61? How old was she when she died? Okay, so if she was 24 in 1910, she died in 1951. That's 41 years later. 24 plus 41, right, is 65. So she died at 65 years, maybe of Huntington's. So you're going to use this information to fill out all of the data for all of the people in this pedigree. And it's a juicy family tree. Like there's some gossip in here. You're going to enjoy it. So first you fill out this pedigree. Okay. And again, you fill out as much of these questions as you can based on that information. Next, you go to the molecular genetic testing. The first thing you should do is you should read about polymerase chain reaction, which we've learned about in class, the use of copying your DNA and using DNA primers to copy specific genes. You're going to use this molecular testing information, okay, and you're going to use it to figure out all about Huntington's disease and all about the number of repeats they might have in their genome. So as you will have read previously, in Huntington's disease, the number of CAG repeats will determine your likelihood of getting Huntington's disease. And I'm not going to tell you the amount because that's something you have to read about. So at this point, I would pause the video and do the pedigree, the names, birth dates, death dates, whether or not they had Huntington's, symptoms, and things like that. Do this first. When you're done with that, start the video again at this point. So I'm going to pause for a second. You can pause the video here. Okay. Once you've done with the pedigrees, you're going to add to the pedigree using the molecular genetic testing. Okay. So in the molecular genetic testing, you're going to get a second set of data. The second set of data looks like this. And what I need you to realize is here's the DNA for the Huntington's gene. And in the middle of the gene are these repeated CAG sequences. The more you have, the more likely you are to develop Huntington's. So in this data set, this gives you a second set of information. How many repeats, how many CAG repeats does this person have, right? So for instance, it says Paula knows that her genotype is 1312. So if you looked at Paula's homologous chromosomes, one chromosome would have 13 CAG repeats, which we would code with as a little h because 13 repeats isn't likely going to lead to Huntington's. And her second homologous chromosome has 12 repeats. So she's little h, little h. That's her genotype, right? And that's her genotypic breakdown 1312. Okay. Now, not everybody on here is going to have you're not going to know their number of repeats. For example, right, Martha died before you found out how many repeats she had. But you would have to find Paula in this family tree, and under her information like this, you would say 13, 12, so you know how many repeats she had. Christina, for instance, okay, was tested for Huntington's the year her father died, and her repeat count was 93.7. So one of her homologous chromosomes had 93 CAG repeats, and one had 7. So we code this as a big H. 93 repeats is going to give you Huntington's, and this is a little h for the 7 repeats. So you're going to add underneath their things like 1312, 93.7 underneath this information. So this is a second set of information you would add to your pedigree, and I would recommend using a different color for that. So you have the birth and death years, how old they were when they died, maybe they had Huntington's, and then add 1312 or 93.7 or whatever. Obviously, you wouldn't add under Martha because I'm talking about Paula and Christina, but you get my point. Okay, now this comes to this part of the lab. The other thing I would like you to do is I would like you to look at the molecular genetics part of the lab and fill out as many parts of the information as you can on pages 7 and 8. So I'm just going to show you my example here, okay? When they did PCR, they're isolating the section of the gene that has the CAG repeats in it. So this part of the gene, so the dark highlighted part here is the forward primer. The dark highlighted part here is the reverse primer. So this is the area they're copying in PCR. This is all part of the gene that's not highlighted. This is all part of the gene that is highlighted. That part of the gene stays the same for every single person, okay? Because this is not related to the CAG repeats. So you can count up the number of nucleotides here, okay? And that goes under the number of trinucleotide repeats over here. I'm sorry, that goes under the number of bases that's the same. So there's 114 bases that are stable from person to person, okay? What we're looking for is how many repeated CAGs we have in there, and that lets us know whether or not this person is going to be more prone to Huntington's. So in this particular example, this 114 base pairs always stays the same, but this part changes. So if you count the number of CAG repeats there's 19 CAG repeats in this highlighted area, okay? And this person then has 57 nucleotides in this region because it's 19 repeats times 3 because there's 3 nucleotides. So there's 57 additional nucleotides here. So this is the 114 bases that stays the same, and this is the 57 additional nucleotides, okay? So the number of bases that stays the same is 114, the unhighlighted area. The number of repeats was 19, CAG repeats. The number of nucleotides contained in that repeated section was 57. So their PCR product, the entire piece that would be copied, would be 171 base pairs. So this is an example, okay, of what I want you to do on pages 9 and 10. So I'd like you to do up until question 7, stop here on pages 9 and 10. How many bases stays the same for Gina and Nathaniel? Here's their number of repeats. How many nucleotides would that be? What would be their total fragment size? So I want you to get to here in the lab and pause there. Okay, so that's what I'd like you to do in class. I'd like you to do the pedigree for the personal information and the pedigree for the molecular information, and answer the lab questions as well as you can up through here. And then next class, we'll pick it up and review it together. Thank you so much for watching my video.